Hey, my name is Ari, and today I'm going to be explaining to you epistasis. So, what is epistasis? Is it trickery? Is it magic? No, it's simply masking. So, a little bit of definitions. It's the expression of alleles at one locus masks or modifies the expression of other alleles at other locus. Therefore, multiple different genotypes lead to the same phenotype. And that is the main thing we are looking at today. Different genotypes lead to the same phenotypes. Shout out Dr. Halweg. Another note is that this is not dominance. So this is not an interaction between alleles at one locus. However, it is an interaction between two different genes. Now that's going to make a little bit more sense here on the next slide. So to simplify epistasis, we're going to be talking about dogs because everybody loves dogs, but not everybody loves genetics, unfortunately. We're going to go over a single recessive epistasis trait, which is one of the many different ways of epistasis occurring. And so this is what we see as a general biochemical pathway explaining this phenomena. So this is not an interaction between alleles at one locus. This is an interaction between two different genes, enzyme A, enzyme B, producing two different enzymes. Okay, so one way to think about it is you got to learn how to crawl before you learn how to walk. You can't just go straight to walking. So therefore, without enzyme A being expressed, the pathway to enzyme B cannot occur, and you don't get any orange doggies. So we're looking at dogs. So we're going to say the yellow precursor is a yellow dog. We're going to say once enzyme A is activated, we get a pink intermediate, and if enzyme A and B are both activated, then you can get an orange dog. So remember, even though B, right here, this guy may be present, you weren't able to get to this pathway. You can't move any further. Therefore, you stay at yellow. So, like I said, you must learn how to crawl before you can walk. Say we do a dihybrid cross of two doggies. This is what our Punnett square ends up looking like, and we're going to get a 9:3:4 ratio because this little guy right here didn't get to go through any of the pathways as seen before. These three right here didn't make it to the pink pathway, so therefore they stayed yellow. This pathway illustrates they have the B available, however this A enzyme wasn't able to be activated. So this is not a simple Mendelian prediction. This is a 9:3:4, so that is why it's epistatic. These guys right here all get paired together rather than it being a 9:3 to 3:1. Another example here, we have a non-dihybrid cross, and in the end you have these two guys and these two guys getting a 1:1 ratio. And while the dominant B is present in these two, there is no A, and therefore the pathway cannot be complete.